Well, all right. This time I'm going to do something a bit different. I'm going to talk about a manifesto that I've written. A manifesto that has the intention to set out some rules for to create a more noble science of physics. So the implicit statement therein is, of course, that nowadays we do not have a physics profession or a physical science that could be regarded as noble. So I would have it to be more noble. And you see, this manifesto that I've written is just this one page. I can show you. It's here in front of me. It's just a small text, but it has an introduction, and the introduction is about 8 pages long. And in that introduction, I sort of analyze the problems in physics. So what types of problems are there? And I analyze that there are, in fact, 2 big problems. And one is that, physics has become ineffective. In the Second World War, the bomb, the nuclear fusion bomb was created, and after that was of course a huge success from a scientific point of view, but it was of course not the kind of success that one should hope for one being a physicist. And it was also, let's say, a point of return for physics there, where people started to look upon physics as something almost godlike, and physicists became sort of half gods, and that put them in a position of power. And what we see from there is that they sort of try to hold on to that power. And huge sums of money went into research for physics, but if you look at it, that research, although research last decades has cost billions of dollars, the amount of results, the actual results coming out of this research, become less and less and less by the decade. I'm not going into all the details of that. You can read the manifesto and the analysis for yourself. It's in the link below. That is another part of the problem that I want to discuss. So first part of the problem is the decline of effectiveness of physics. And the second is immunization strategy against critique. If I, for example, try to start a discussion about some of the basic points of physics, let's for example, I want to discuss the quarks. I'd say, well, I think quarks do not exist because they are only some sort of theoretical construct, and I have alternative theoretical construct that is far simpler, etc. If I want to open a discussion of that type, there is no place that I can do that. If I write an article about it, no physical journal will publish it. And if I am going to, let's say, open a discussion on a forum on the internet, the discussion the topic is deleted within the hour or within 24 hours by a so-called moderator, and they think that it's perfectly normal to kill that sort of ideas, because you need a peer-reviewed article in order to start a discussion on such sites. Well, I think that's just plain stupid. I don't know what you think about it, but it looks to be, like I'm in a George Orwell novel, 1984, where you have this concept of newspeak, and where just words are not allowed for concepts that are not allowed. So we try to sort of, it looks like, the physics has been trapped in a sort of a vocabulary that they use, and a sort of a basic set of ideas that they use, and everything outside of that mainstream is, well, sort of ignored, deleted, kept away, etc. You can read all about it in the paper. It's more detailed in a link below. So let me go on to what is then the solution, because if you become less and less effective, and you start to immunize yourself against critiques, or no news ideas enter the realm, and your belief system is sort of closed, then what's the way out? So, and I've put forward 7 rules, and I will just go into them and try to blow some life into them while talking about them. So the first rule is ontology over mathematics. I just said that in physics has become sort of godlike. Well, within physics, mathematics has become sort of a god, as a sole revealer of truth. Many physicists, they look upon mathematical formulas that they have created as a revealer of truth. They look into these formulas and in the hope that these formulas will reveal some new type of reality to them. And that's, of course, just wishful thinking. It is not the physics that I envision. The physics, I think, has to be based on descriptions of physical processes, and that is why I say we need ontology over mathematics, because ontology is about describing reality as it is, or as we think it is, or describing it as close to reality as we can, and not putting abstract layers of mathematics instead of them. So we should avoid using long trains of mathematical derivations as substitutes for real insight into physical processes. So the physical process should be at the center, and then we use mathematics to quantize, to try and calculate something about this physical process. So it is not the first part of the manifesto, sort of first rule of the manifesto is not about discarding mathematics, not at all, because mathematics is very important. But ontology, so the real description about the physical process, should come first, and only then we use mathematics in order to make more sense of it and to prove that the process that we have described is consistent with reality. Now, the second rule is universalism over context. It's easy to just describe, put forward a theory that only describes a small part of reality, and then obtain high accuracy just in that specific part of reality. For example, we have the high accuracy or claimed accuracy of the electromagnetic moment of the electron by quantum mechanics, a part of quantum mechanics called QAD, and this claim is that they can sort of calculate the electromagnetic moments of the electron within, say, 6 or 8 digits, and that is, of course, a high accuracy. But what is the value of this accuracy? Apart from that, it hasn't got any practical value at all. The value, to obtain precision in a very isolated part of reality, in a very small theory that is only produced to explain small parts of reality or small sets of physical events, that is not a gain. The real gain should be to make theories as universal as possible. So what we should do is produce a theory that does not, for example, only explain the electromagnetic moment of the electron, but also of all other particles. So why is there this spin? And there is only one theory explaining the spin of all particles, and not just this one single particle, only the electron. So that is the second rule: universalism over contacts. Try and make theories as universal as possible. Then there's the second one: methodology over validation. Nowadays the methodology seems to be limited only to producing a model of reality and then validating that model, and then within that model you can have all sorts of assumptions, like it's sort of a big book of assumptions, and all these assumptions are suddenly validated when there is only one experiment that validates it. And I think that is hugely flawed. What we should do is to put methodology in the center again. Like, what is it, this observation that we do? What's the meaning of that observation? What can we conclude from it? I've written in my book, Monkeys Do Not Die as Lizards, there's an annex where I share my methodological considerations with my fellows physicists, and I hope they're inclined to learn something about it. So that was the third one: methodology over validation. So that doesn't mean we do not have to validate theories, but that means that we should methodology in the center and not only limit ourselves to validation of models. Now, the fourth rule is to make concrete or more valuable than abstract. So the rule is concrete over abstract. And what I mean with that is that, we have so many theories now that talk about virtual particles being affected by virtual speculative fields that go in and out of existence, etc. And we talk about what goes on inside of black holes, sort of plasmas, quark, plasmas being created there through some sort of abstract process that can be calculated with some sort of mathematical formalism. We have delved into such abstract worlds that there is almost no connection with reality anymore for a vast majority of scientific papers being published. And what I would like to happen is that we talk about concrete things again. There's much talk about entanglement, for example. Well, entanglement is a very abstract thing. It can only be shown to exist using statistical mathematical formalisms that show, well, there we have some entanglement. But what really the concrete physical process of entanglement is, nobody is able to explain that. So I think that it is very important to go back to the concrete descriptions again, and only resort to abstract considerations, abstract concepts when absolutely necessary, when we do not have a concrete alternative. Now, the fifth rule is that I would like to see equality over elitism. You have in physics, they talk about crackpots all the time. If you are in mainstream, you try not to be a crackpot, because crackpots, they don't know the difference between, let's say, gravity and electrostatic force. And so they're ignorance, and there's nothing in between. So you are either part of the elite that does understand physics and all these complex mathematical formalism, or you are outside. And there's no place in between. Well, I think there are many so-called outsiders that have very important lessons to tell. So equality should be put first. That if someone has something important to tell you that is of substance, then the mainstream physics should listen, and they should listen to each other. So equality over elitism, I think that's a very important one, because before you know, you have sort of groupthink. All people start to think the same, and if you express only an idea that's a little bit outside of mainstream, you are met, with a huge sort of disdain, and that's wrong. People should regard each other as equal partners in physics and thinking about nature. Now, the sixth one is truth over effects. So, many theories are produced with the idea of sort of enchanting popular media. Like for example, we have created a wormhole in a quantum computer, which is constant nonsense. But people find that interesting to hear. They want to hear such stories, so we produce these stories, and that is wrong. If you read my book, Monkeys Do Not Die as Lizards. The theoretical constructs that I have produced there are solely based on the intent of finding the truth, and there's no effect in them whatsoever. So sometimes this truth is sobering, and there are more people I know that flock around affects, flock around interesting lies instead of those who flock around sobering truth. But I'm for the sobering truth. I want to use, that's what I do, and that's why I've written my book. So that's the sixth one: truth over effect. And then the last one, quality over quantity. So, it looks like many physicists, I don't know in the other branches of science, but it looks like it's the same illness there, that, if you have an article, you write it in a manner, that you get past peer review as soon as possible. And therefore, you cannot, if you have some very innovative idea, it will not go past peer review very quickly. So if you want high scores, and many articles written, many articles going through peer review, so that you can just sort of get the 200 articles on your name, on your website, that is not the way to go for physics. If you want a noble physics, and that's why I have written this manifesto for a noble physics. If you want a noble physics, then you should favor quality over quantity. So that's my manifesto. You can read all about it on the link below. You can download it. It's for free, as all my articles and all my books can be written for free. Of course, you can also buy my book if you want it on bol.com or whatever. But almost everything I've written is also available for free. If you liked this video, please give me a thumbs up, and I'll be glad to see you next time. Bye bye.